Hi, I am glad that you are here. I am still experimenting with my microphone, so just appreciate that I'm not singing you with us. So, the question is whether phase diagrams are essential for soldering or not. Absolutely not, I just found them useful. And what is a phase? A phase is a part of the material where physical and chemical characteristics are homogeneous. This is also true if the material is not in one piece. The material can be single phase and single crystal at once, like this piece of salt, or single phase with many crystals with different orientations. Your soldering wire won't be like this. At least two metallic components and phases will be present in a more special form. The easiest to start with the lead-tin phase diagram. The horizontal axis shows the concentration of the two elements, pure lead on the left, pure tin on the right, and the vertical axis is the temperature in degrees Celsius. There are temperatures where the whole thing is liquid at any ratio of the components. The lower threshold of this zone is called the liquidus line. And then there are two temperature/concentration zones where the material is solid. It has a typical crystal of the primary metal, and the other metal is a solute in that. We have here the lead-rich alpha phase and the tin-rich beta phase. Now we can also read the melting point of the two metals. It can also happen that the solid phase has to precipitate out from the liquid in small grains and making a mixture with the liquid. The temperature where these solid-liquid mixtures have to freeze is called the eutectic temperature. Here it is 183 degrees Celsius. I mean on the picture, not in my room. And below this we get some mixture of the two solid phases. Let's check out a specific case. We have 40% of tin and 60% lead by weight at 250 degrees Celsius. It is a homogeneous liquid and we start to cool it down. It reaches the liquidus at 204 degrees Celsius and alpha crystal starts to form and then grow with further cooling. When the temperature drops down to 183, the remaining liquid transforms into a lamella-like solid alpha-beta mixture all at once. How do we use this knowledge for soldering? Do you see that green dot on the screen? Our liquid will go instantly into solid without any granulation if we cool it through that point. It happens at 61.9% tin concentration, exactly at the bottom of the liquidus line, and that also indicates an ideal low melting point for our alloy, which is 183 degrees Celsius. This is why most leaded solders contain from 60 to 63% tin. Finally, we should check out the tin-copper phase diagram for two reasons. The European Union banned leaded solders for most cases in 2006, and solders became highly tin-rich. On the other hand, the solder has to create some kind of bond with the copper of the PCB. The diagram is more complicated than the previous one, but I must highlight these. These are the intermetallic compounds. Their conductive and mechanical behavior has a negative effect on the solder joint and they create some reliability issues, but their presence is essential since they create a bond between the copper and the tin, just like an interface. And maybe I will try to talk about them in the next video. Thanks you for watching. I hope it helped.